Hey everybody, we're here today to talk about the Lewis structures of binary ionic compounds. Before we begin that process, it's important to remember a couple of things about ionic compounds. First, ionic compounds are formed from the transfer of electrons from positive cations to negative anions. And that when a stable ionic compound forms, the total positive and negative charge that is present in one formula unit of that compound cancels each other out so that we have a zero sum charge. When we talk about the guidelines for forming or for drawing the Lewis structures of ionic compounds, the first thing we want to keep in mind is that it's not really feasible because of the non-directionality of the bonds in ionic compounds to draw the whole compound. Instead, what we're going to talk about drawing is the structure for one single formula unit. Now, in terms of guidelines for drawing the Lewis structures themselves, it really can be broken down into 3 steps. Number 1, we're going to draw the Lewis structure for each individual atom that is involved in the compound. Number 2, we're going to draw the Lewis structure for the ion that forms from each of those atoms. And of course, it might be helpful at that point to have a periodic table handy. The other thing to remember is that when you draw Lewis structures of ions, anions, the negative ions are always placed in brackets. And the charge of each ion, both cation and anion, is written as a superscript after the Lewis structure of the ion itself. Finally, we're going to combine the Lewis structures of each of those ions in such a way that the total charge on the compound, or the formula unit of the compound in this case, is equal to 0. We're going to use coefficients in front of the Lewis structure of each of the ion types to indicate how many of each of those ions are present in the compound. This whole process is perhaps best illustrated by a couple of examples. So, let's do 2 examples today. Let's look at first the Lewis structure for the ionic compound that forms between magnesium, Mg, and oxygen, O. Let me turn on my pen here, and I'll work this with you. Let's use blue today. First thing is first, we have to draw the Lewis structure of both magnesium and oxygen as separate atoms. So, magnesium, being located on period 2 of in group 2 on the periodic table, has 2 valence electrons. We might draw its structure like this. Similarly, oxygen, O, being in the 6th A period, or 6A group, or 16th group, has 6 valence electrons. We might draw that like this. Step 2 is to draw the Lewis structure of the ion that forms from each atom. Now, again, magnesium, being in group 2 or 2A, has 2 valence electrons, and we know that when it forms an ion has a 2+ charge, which means it's going to lose both of the valence electrons it currently has. So its structure will transform to simply Mg with a 2+ charge. Note, there are no dots. Both have been lost. Oxygen, on the other hand, being in group 6A or 16, has 6 valence electrons. When it forms an ion, it gains 2 electrons to have a 2- charge. Now this is an anion, so we're going to have to place it in brackets. So an open bracket is an appropriate start. Then an oxygen atom, and now it is going to be surrounded by 8 dots. It gained 2 electrons. We close the bracket and write a 2- charge. The last step is to combine these 2 Lewis structures of the ions into a neutral compound. To figure out how to do that, we have to assess the charge. Magnesium has a 2+ charge. Oxygen has a 2- charge. That means that if we put one magnesium together with one oxide ion, we're going to get a total charge of 0. In other words, for this structure, there will be no need to include any coefficients. The final product, combining these together, is simply going to be Mg2+, bracket, draw our oxygen. Apologies for the sloppy dots there, you all. Second bracket, 2-, and we're done. Let's look at a second example that perhaps is a little bit more complicated. In our second example, we'll use barium, Ba, and chlorine, Cl. Again, we'll start at the beginning. Let's draw the Lewis structure for the barium atom and the chlorine atom. Barium, again like magnesium, is in group 2 or 2a, and therefore has 2 valence electrons. Its Lewis structure might look like this. Chlorine, on the other hand, is in group 7a or 17, and therefore it has 7 valence electrons. It might look like this. Now we have to draw the structure of the ion that will form from each of these atoms. For barium, again, group 2 or 2a on the periodic table, going to form an ion with a 2+ charge. Therefore, both of its dots are going to disappear. Chlorine, on the other hand, is in group 17 or 7a. It's going to form an ion with a 1- charge. In other words, it's going to gain 1 dot. And of course, because it's a negative ion or anion, we're going to place it in a bracket. The last step is to combine the structures of these ions into a compound that has a net charge of 0. This time, it's a little more complicated. The barium has a 2+ charge. The chloride ion has a 1- charge. This time, to make the total charge equal 0, we will need to have 2 chloride ions. And our final structure can be drawn like this. Our Ba, barium ion, bracket, a number 2 for the 2 chloride ions that we will need, a bracket, the dot structure for our chloride ion, close the bracket, and a 1- charge. Note, we have a structure now that shows 1 barium ion and 2 chloride ions combining together to form the ionic compound barium chloride. And the total charge on that compound is equal to 0. I hope you found this video a little bit informative. Stay tuned for future videos about other Lewis structures and many other chemistry concepts. Thanks for watching.